Okay, now let us discuss class 11 mathematics chapter 2 exercise 2.1. Read the first question. Here two ordered pairs are equated and you're asked to find the values of x and y. So write down, the question is set of ordered pairs. So x over 3 plus 1 comma y minus 2 by 3 is 5 by 3 comma 1 over 3 or 1 by 3. Now since both the ordered pairs are equal, which means x coordinate must be equal to x coordinate, that is x plus 1, x over 3 plus 1 or x by 3 plus 1 equal to 5 divided by 3, and y minus 2 by 3, 2 divided by 3 is equal to 1 divided by 3. So this implies x by 3 equal to 5 over 3 minus 1. So you multiply throughout by 3, you get x equal to 5 minus 1 times 3 is 3. So that gives x is equal to 2. And here this gives y is equal to 1 over 3 plus 2 over 3. It's also common denominator. So you get 3. 2 plus 1 is 3. That's equal to 1. So y is equal to 1. So you're asked to find the values of x and y. So you got x is equal to 2. Y is equal to 1. And if the set A has 3 elements and set B has 3, 4, 5, then find the number of elements in A cross B. So it is 3 by 3, it's 9 elements, because n of A is 3, n of B is also 3, therefore n of A cross B is 3 times 3, that's equal to 9. Okay, a set of ordered pairs, right? So you take any elements of set A, say for example A comma B comma C, then A will be combined with 3, A comma 3, A comma 4, A comma 5, 3 elements. Then with B, B comma 3, B comma 4, B comma 5, again on more 3 elements. Then with C, C comma 3, C comma 4, C comma 5. So you get 9 elements. Okay, so that is this. So you just multiply the number of elements of set A with the number of elements of set B, you get the number of elements of A cross B. And so G is, set G is 7, 8, and set H is 5, 4, 2. So G cross H is set of ordered pairs of 7, 5, then 7. Take the first element in the set G and pair with each of the elements in set H. 7, 4, 7, 2. Then take 8, 8, 5, 8, 4, and 8, 2. So this is the set of ordered pairs of G cross H. Now H cross G is, now the first element you have to take from H, so it is 5, 7, 5, 8, then 4, 7, 4, 8, then take the first element from H and second element from G, it's 2, 7, and 2, 8. So that's how you find the set of ordered pairs of G cross H and H cross G. Then question number 4. State whether each of the following statements are true or false. If the statement is false, rewrite the given statement correctly. Okay, first question. If P is Mn and Q is Nm, P cross Q is M, N and N, N. So this is false. So the correct statement is P cross Q is, first take the element from P, first element M, then pair with each element of Q, M, N, M, M. Then take the second element N and pair with each element of Q, that is n comma n and n comma m. So this is the correct answer. So here two elements are missing, that is m comma m and n comma m are missing. So that is false. So second question, if A and B are non-empty sets, then A cross B is a non-empty set of ordered pairs x comma y such that x belongs to A and y belongs to B. It's correct. So if A and B are non-empty, then A cross B is also a non-empty and set of ordered pairs of x comma y such that x belongs to A and y belongs to B. That's correct. So it's true. The statement is true. So you get x comma y means set of all the ordered pairs where the first element is from set A and second element y is from set B. That's correct. Then third question, if A is 1 comma 2, B is 3 comma 4, then what is A cross B intersection empty set? Is empty, is given. It is true because though there is no need of reasons, I'll just explain that. So B intersection empty set is empty set. So therefore A cross B intersection empty is A cross empty set. So since empty set has no element, you cannot form an ordered pair with A, so that's again empty. So this is true. And question number 5, if A has -1 comma -1, find A cross A. Okay, so you just do it stage by stage. So you have consider 3 elements. So it is A cross, first you can find A cross A, so easy for you. That is -1 comma -1, -1 comma 1, 1 comma -1 and 1 comma 1. Therefore A cross A is, you cross with one more A here, so that is take -1 first. So -1 comma -1 comma -1. Then again first element is -1, so you just do like that. So if -1 with pair with all the 3 elements, -1 comma -1 comma 1, -1 comma 1 comma -1, -1 comma 1 comma 1. Sorry. Then you take the second element of A and pair with all the elements of so next element is 1 comma -1 comma -1, 1 comma -1 comma 1. You just add with pair with these 4 elements, and 1 comma 1 comma -1, this one, and with the last element 1 comma 1 comma 1. So close the bracket. So there are 8 elements are there. Okay, then that's the answer for that. Now A cross B is given, find A and B. So A is, collect all the first elements. A, that is your A. So A is A comma B, A 2 times B, and B is the second elements. So that is x comma y. In set of ordered pairs, the first elements are from set A if it is A cross B, then second element is set from set B. So you collect all the first elements in the ordered pairs, you get the set A, and you collect all the elements, second elements of the ordered pairs, you get the elements of B. So you get B. So A is A comma B, B is x comma y. And question number 7, let A equal to 1 comma 2, B is 1 2 3 4, C is 5 comma 6 and D is 5 6 7 8. Verify that A cross B intersection C is A cross equal to A cross B intersection A cross C. So it's a distributive property, you have to check that one. So let us do one by one. So we need A cross B intersection C. For that you write down A first, that is 1 comma 2, and B intersection C. So collect B intersection C is 1, 2, 3, 4 and 5 comma 6. No element is common, so just an empty set. Okay, oh, it's empty. Okay, therefore A cross B intersection C is A cross empty set equal to empty set, and A cross B is at 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, and second element of A is 2, pair with each element in B, so 2 comma 1, take 2 and pair with each element in B, 2 comma 1, 2 comma 2, 2 comma 3 and 2 comma 4, and A cross C is, take A and C, so take first element in A, pair with each element of C, that is 1 comma 5, 1 comma 6, then take second element, pair with each element of C, so 2 comma 6. Now when you compare these two sets, A cross B intersection A cross C, so no element is common, so there is also an empty set. So this is 1, this is 2. Therefore from 1 and 2 we observe that A cross B intersection C is equal to A cross B intersection A cross C. So that's proved. Now second set, A cross C is a subset of B cross D. So let us find A cross C first. So A is 1 comma 2, B is 1, 2, 3, 4, C is 5, 6, D is 5, 6, 7, 8. So you have to prove that A cross C and B cross D. Okay, first you find A cross C, A and C. So you get, take A is 1 comma 2, B is 5 comma 6. So first element of A and compare with pair with each element in C, so 1 comma 5, 1 comma 6. Then take second element of A, pair with each element of C, so 2 comma 5 and 2 comma 6. Then you have to find B cross D. So B cross D, take each element of B as the first element and pair with each element of D. Take the first element now, so it is 1 comma 5, 1 comma 6, 1 comma 7, 1 comma 8. Then with 2, 2 comma 5, 2 comma 6, 2 comma 7, 2 comma 8. Then 3, third element in B, 3, you pair with each element of D, so 3 comma 5, 3 comma 6, 3 comma 7, 3 comma 8. And fourth element 4, 4 comma 5, 4 comma 6, 4 comma 7 and 4 comma 8. Now when you see that 1 comma 5 is there, 1 comma 6 is there, 2 comma 5 is there, 2 comma 6 is also there. Apart from that, remaining elements are there in B cross D. Therefore we conclude that A cross C is a subset of B cross D, or you can write a notation, A cross C is subset of B cross D. Okay. Then question number 8. Set A has 1, 2, 2 elements, and set B has 3, 4. Now write A cross B. So you have to write A cross B, and A cross B is 1, 3, 1, 4, 2, 3, 2, 4. So this is the elements of A cross B. Now how many subsets will A cross B have? So power set, subset is given by n of A cross B is 4. So subsets n of P of A cross B, the formula is 2 power 4, that is 16. So number of subsets of a set is called the power set, denoted by P. So P of A cross B is 2 to the power n. If n of A has m elements, then n of P of A has 2 power m. So already we have seen the result, so you can recall that. So now we have to list them. So therefore power set P of A cross B, that is set of all subsets. First you write the singleton sets, that is 1, 3, 1, 4, 2, 3, 2, 4. So set of ordered pair of only one pair each. Then 2 sets at a time, 1, 3 with 1, 4, 1, 3 with 2, 3, then 1, 3 with 2, 4, and 1, 4 with 2, 3, then 1, 4 with 2, 4, then 2, 3 with 2, 4. So all these sets 2 times. So that's all with 2. Now take 3 at a time. First 3, that is 1, 3, 1, 4, and 2, 3. Then 1, 2, and 4. 1, 2, and 4. So 1, 3, 1, 4, and 2, 4. It's a set of. Then 2, 3, and 4. 2, 3, and 4. So their elements 1, 4, 2, 3, 2, 4. So we have listed all the elements, three elements taken at a time. First 1 element taken at a time, singleton sets, then 2 elements taken at a time, then 3 elements taken at a time, and all 4 elements taken at a time. 1, 4, 2, 3, and 2, 4. Then at last empty set, then close the bracket. Now count the numbers of the sets here, because the full set itself is a subset and empty set is another subset. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We missed 1. It should be 16. So first element, first and 2, first and second, first and fourth, then second and 3, second and 3, okay, second and 3, second and 4. Oh. First element and first element, first all fours, okay, two elements at a time, first and second, first and third, first and fourth, okay, then second and third, second and fourth, correct, second and third, second and fourth, and third and fourth. Okay, that's also correct. Then 3 at a time. Anything is left here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so taking 3 elements at a time. 1, 2, 3, 1, 2, 4, 1, 3, 4. That is 1, 3, 4. 1, 3, 4. Okay. Then 2, 3, 4. 3, 4. 1, 3, 4 is missing. Correct. So we have to add one more element here. So okay. So yeah, see, we have taken 1, 2 and 3. 1, 2, 3. 1, 2 and 4. 1, 2, 4. Then 2, 3, 4. But 1, 3, 4 is missing. So 1, 3 and 4. Yeah. Then set of all elements, all 4 taken. So 1, 3, 1, 4, 2, 3 and 2, 4. Then empty set. So we have 16 elements. Okay. So this is how we find the power set, that is number of subsets of any set. So here set itself is an ordered pair, so you have to be careful in collecting the sets. First all singleton sets, then take 2 elements at a time, then 3 elements at a time, and 4 elements at a time, because the set has 4 elements, and empty set. And question number 9, let A and B be 2 sets such that n of A equal to 3 and n of B equal to 2 if x, 1, y, 2, z, 1 are in A cross B. Find A and B where x, y, z are distinct elements. Okay. So A, the first elements form the set A. So A is, find A, set of all elements of the first elements. In all the ordered pairs, you collect all the first elements, that's your A. Because A cross B is there, are subsets of, are elements of A cross B given. If these are the elements of A cross B, then you take the first elements, x, y, z is set A. And B, 1, 2 and 1, but they are given distinct elements. So you have B as only 1 and 2. 2 only distinct elements. It's not repeating, that's why they are given distinct elements. So, okay, so that's what you want to find A and B. Then the Cartesian product A cross A has 9 elements, among which are found -1, 0 and 0, 1. Find the set A and remaining elements of A cross A. So now A has distinct elements. Which are found. A cross A has 9 elements. That means n of A should be 3. So n of A cross A is 9 elements, which implies n of A is equal to 3. And given A cross A has elements -1, 0 and 0, 1. So we need to find the elements. So for that we have to find set A first. So A has -1 first elements 0, Okay, so and again A cross A, the second element also 1 is there, so this 1 is also there, so A has also 1 because 0 1 has 1. Therefore now you take A cross A is negative 1 0. You write in order now. So first element with first, okay, let's go by order. First element with first element, first element with second element, first element with third element, then second element with first element, second element with second element, second element with third element, and third element with first element, third element with second element, and third with third. So there are 9 elements are there. So you choose this first because it is A cross A. First you collect the first elements negative 1 and 0, so you got it. But again you look into the second element, that is also in set A, 0 and 1. Therefore already 0 is there, so 1 is the third element. So like that we found the elements of set A first. Then from there you can find A cross A, write in order, you get. Now we observe that minus 1 comma 0 and 0 comma 1 are 2 elements, one of the elements in that full set. So that's how you find the answer for this question. So that completes the answer for this exercise.